So, hello everybody. Welcome to my talk. I think it's time to start. I hope you can hear me. Maybe a thumb up in the chat would be great.
We hear you just fine.
And you see the presentation? That's good.
Yes, very good.
Okay, thank you. Yeah, so my talk is about the automation of the Yocto layer maintenance. So I'm working for AWS, maintaining the meta-aws layer. Yeah, and I did some Yocto related work in a previous company. So I'm using Yocto for more than 10 years now and doing this maintenance job at AWS for over around about half a year. So what's our goal? Our goal is to provide our latest software to customers with meta-aws. As you know, AWS has a lot of services and we have software to connect with the services, to use the services. It's IoT related, some of them, some command line tools. And yeah, we want to have always the latest software released. And yeah, there is a problem. So the problem is we have 48 recipes and the number is growing. We're supporting 4 releases with that recent software upgrades. So it's the LTS, Kirkstone, Dunfell, yeah, and master branch. And we have 3 processor architectures to test. So we support ARM64 and x86-64. That makes 12 builds tests for each upgrade recipe upgrade, and some of them release daily. So as we all know, manual tests are not good. Daily releases and that manual work, it's a lot of time if you have to do it daily manually. And so we have thoughts on these problems, and the solution is automation, but we don't want to ship broken recipes. So if we do an upgrade, we have to test them before we commit and release them. So what are those tasks I'm talking about? We do an upgrade, and after we did a recipe upgrade in that meta-aws layer, we test that upgrade, the 3 architectures and some additional tests I will talk about. And after this, it's integrated, means committed, then released to the one of the 4 supported branches, master and the LTS and the current release branch. And after this is backported to the other release branches I was just talking about, and then it's tested, integrated, and released. So this is a lot of work. So in detail, what are those tasks? Upgrade tasks. That means, somehow the upgrade should be triggered. That can be manually or daily by a cron job or some webhook kind of thing. So whenever some release of package is triggered, then that update process should be triggered. And that means, modifying the recipe, the file name, which usually has the version number in it, some kind of source revision, a commit hash, git hash thing, maybe some patches adjustments if they are still necessary, if there are modifications necessary. Yeah, what we figured, that dev tool is great. If you don't use it, you should try it. It can already do a lot of those things already out of the box, and it works just fine. So what does this test mean? As said, there are 3 architectures. We want to build on them, that the build runs. And then we want to have some kind of run tests. So we don't want to build and ship. We want to know that the software or library is usable. As said, integrate means commit to the dash next branch. Release is a fast forward merge from the dot next branch to a release branch. The backport thing is yeah, doing a cherry pick to the other branches, and they also need tests. So let's talk about technologies. We use GitHub already, so we are on our home base is on GitHub. And we use pull requests for contributions like fixes or new recipes. Yeah, we want to stay with GitHub. And yeah, the first thing that came up into our mind was, yeah, maybe use GitHub Actions somehow. And yeah, as said, I'm working for AWS. We have a lot of services, technologies. We have a lot of knowledge. So if we do something with that services, technologies, we have some internal resources to ask if there's a problem. Yeah, we don't want to any physical dedicated build hardware. We have enough cloud resources, and yeah, we want to have a scale to zero solution, so not running like a build machine 24 hours during the week. Only if we do the tests, it should be run. And yeah, of course, use something like infrastructure as code. That setup is maintainable and reproducible. So what's our approach? A short overview diagram. On the left yellow side, there's the upgrade task. The upgrade task is started by a cron job. It's a GitHub action that runs at midnight every day, and it starts a Python DevTool wrapper script, which creates pull requests, GitHub pull requests in the test section there, in the purple one. And that pull request will start 3 different tests by now. One of them is a check layer test, so that we can keep our nice Git Yocto compatible batch. And the other thing is a lint checking tool, which helps you to have a well-formatted recipe. And the other thing is what I just mentioned is the build and the p-test code build test. So what's AWS code build? I will have a slide on this later. After those builds are okay, there's an integration step, the blue one. It's a GitHub action that will do an auto merge of that pull request into the dash next branch. And after this is done, there is a backport action, a GitHub backport action, which will create pull requests to other release branches. And that will start the purple test process again. And yeah, the release step is a manual trigger. So we have a GitHub action for this, but it's by now it's a manual step. So that fast forward merge is triggered manually, could be automated, but yeah, it's for security reasons. It's a manual step to have a look at what's committed. Cron job GitHub action. As said, it creates those pull requests. I have linked all that GitHub actions in my slides. They are downloadable as a PDF. The Python auto upgraded DevTool wrapper thing is on a different GitHub repo. It's also linked. It's open source. You can use it. And yeah, and there is a new pull request for each recipe upgrade. So if there are more recipe upgrades, it's for each one. And this is also good since all other contributions, as said, are done with GitHub pull requests, so they can have the same tests. So there's no separate thing for GitHub only contributions. Um, the three tests I'm talking about, the one is the check layer thing. It's a GitHub action. The lint checking thing, it's also a GitHub action. And there is the AWS code build and p-test thing. And so the next slide is about this. What's AWS CodeBuild? CodeBuild is something like a GitHub runner. So it's a service that uses some source code, is triggered, spins up a Docker container, runs that build, and gives some kind of feedback, some results, some build artifact, or just an okay. So on the left side, GitHub triggers a webhook, which is some kind of a function call, you can say. This is starting a Lambda, AWS Lambda step function, which is a kind of a state machine. This state machine is controlling that CodeBuild build instances for different architectures. And those are running in a virtual private cloud, that yellow cloud thing there. And there is also as a state server to speed up the builds. And those as a state server, I have a slide on this later on, is a Docker container as well, which is in AWS ECR. It's a Docker registry, and AWS ECS, which is some Docker service to start containers. Next slide is about that build. So the CodeBuild builds the recipe, and after this there is a test image builded as well in the same Docker container. And yeah, there is some code snippet what we just added. And so our plan is to have like a p-test for every recipe. So with that we can run the p-tests for that upgraded recipe and have a result. And by this command in the lower box, you can just generate a p-test JSON file with that p-test thing. I've linked the p-test wiki entry on my links page on my last slide. So if you don't know about this, there is a starting point for this. So if those tests are okay, there is an auto merge GitHub action. And after those are merged, those GitHub pull requests, those branches are deleted. And if they are not okay, the pull requests are still exist, and they can be like manually fixed. And this is like the same state as there is a normal contribution. So those are failed one of the tests. You have to go into the log files and check what's happened, why it's not okay. The release to the next branch is fast forward merge, as said. It's a manual step, and it's a GitHub action, which is also linked, and you can use it. After this, there's a backport GitHub action, which is triggered after that pull request is merged, for instance, to master next branch. Then it will start backporting to Kirkstone next, to Dunfell next, and Langdale next, and start those tests again. How does this look like? There's a screenshot. For instance, one of our libraries, which is often an update, is Python 3 Boto Core. And On the right side, there you see 6 successful checks. One is that auto merge action. It shows up as a test, but yeah, it's not really a test. Then there is that OA lint checking GitHub action, the Yocto check layer action, and there are 3 builds, the code build thing, which all good. And after this, yeah, it's auto merged, and the branch is then deleted. Problems. Yeah, DevTool is great, as said, but recipes need streamlining. So you need to add some pieces, bits and pieces that the auto upgrades work with the DevTool. For instance, yeah, the upstream Git tag regex thing that allow you to specify what kind of new releases you want to upgrade to. So yeah, what you want to upgrade. Then yeah, there is a GitHub Actions debugging is not good. It's not nice. I didn't figure out how to do it good. So it's yeah, it's more try and error, and there's also thread synchronization is a big issue. So some of our actions need some sleep because otherwise there are problems. But it's working and it's not huge. So that's it's okay to do it this way, I think. Yeah, the build speed, as mentioned, we have an sstate server, so build speed is no problem anymore. On the next slide, there will be something about the build about the state server, and also some numbers I will have a slide on. Yeah, what's another problem, of course, as you know, patches must be applied, otherwise they cannot be auto integrated, patched, backported. So might there is in the future some different syntax for the master necessary. It cannot be easily backported to one of the LTS releases. Yeah, but for now, this approach is good for us. Maybe we stop backporting if there is a problem backporting them. Yeah, but still we can have that upgrades on the master branch then. So as a state server, we have engines to serve a cache tier. We have that hash equivalent server Ross was just yeah, telling about. And it's running an rsync daemon to receive updates from multiple sources. Multiple sources are those CodeBuild instances. If they finish their build, they save their sstate to that rsync daemon, to that sstate server thing, and they only append what's new. So the first build will take long. You will see on the numbers slide next on the next slide, and after this it's fast and it only updates what's the differences. And as shown in that yellow cloud, it's a virtual private cloud environment, so there is no internet connection from the sstate server or something. It's yeah, something for security reasons. Some numbers. We did 600 auto upgrades, pull requests without any big problems so far. That means 10 each weekday, roundabout. For instance, that core image minimal build with an CodeBuild instance, big instance type with 145 gigabytes of RAM and 72 virtual CPUs. Take without as a state server 45 minutes to build. If you have an initial rsync 3.5 gigabytes to the sstate-server. This takes 15 minutes. I'm sure it can be faster, but for now this is just fine. And after the sstate cache is filled, the whole clean build with the p-tests takes less than 10 minutes. It depends, of course, on the test, and of course depends on the change. I mean, if there is some big change and everything has to rebuild, then worst case is, yeah, that 1 hour thing. But yeah, not every day there is a big change. Future work. We want to have nice p-test results. By now it's just showing the log files. We want to show them in GitHub as well. But yeah, probably we have just to dig into log files then if there is a failure. We want to have more and better p-tests for all our recipes. By now, only a few we have p-tests. And we did run into some trouble with binary recipe upgrades with multiple architectures. That means if you have a software which downloads for different architectures, different binary packages, this is not possible by now with DevTool. Yeah, might this is something to contribute to the Yocto project. And as well, there is a bug with Go and Rust recipe upgrades with DevTool. Yeah, that's some work, but we don't have much of them and they are not daily upgraded. So we are pretty happy with that. Conclusion. We did automate our workflow. We did automate tests. Our solution we like because the dev tool is just wrapped. So from developer perspective, you can easily just call dev tool from command line to see why it's not upgraded, where is a problem. Yeah, but if there is no problem, it just works and gives you more time to work on features. Yeah, the technology is there, and yeah, just use it.